Hello, everyone. My name is Matthew, and I'm here with Sarah, Rachel, Andrew, and Caitlin. And we worked with Microsoft to develop a software showpiece that demonstrates how technology can help make smart cities more inclusive. So first of all, a smart city is one that uses information and communication technologies to enhance its livability, workability, and sustainability. Smart cities are a growing market, expected to reach $2.7 billion by 2024. While smart cities are growing, Microsoft wants to ensure that no group is excluded. Unfortunately, the elderly and people with disabilities are often left out in the design of new technology, so Microsoft wants to ensure that inclusivity is a key tenet of smart cities. In order to make the project more tangible, we decided to narrow our focus down to people who live in Boston with a visual impairment. Our project had two phases. We did a lot of research to better understand the accessibility in smart cities. We then identified a problem and spent the second semester building a prototype solution. Throughout the whole year, we continuously led interviews and co-designs with people with visual impairments, and this feedback loop and constant testing of our prototype ensured that we were building the right thing for our users. In addition to people with visual impairments, we also talked to people in City Hall, such as the Department of New Urban Mechanics and the Disabilities Commission. We also went to the Smart Cities Expo World Congress to understand what other people are doing in the smart city space. As a result of our research, here's some of what we learned. Any technology lives on a spectrum from solving problems in the moment to solving problems ahead of time by helping users prepare. So solving a problem in the moment is good because it directly addresses a pain point. But meanwhile, helping mitigate problems ahead of time can help improve independence by avoiding those pain points altogether. This is true of accessible applications for traveling, which is what our team focused on. Each box here represents an existing application and the space that it is designed for. These can be categorized by navigation versus exploration. So navigation is traveling from point A to point B, whereas exploring is free-form travel that can help better understand an area's layout and its points of interest. Many people we talk to mention that they don't spend much time exploring, and when they do, they often rely on a sighted person to tell them what's around. This is unfortunate because people would like to explore more, as it would improve their independence. For our project, we decided to focus on this area on the right and build an application that can help people with visual impairments explore the city before going there in person.
Let's look at a more specific example of traveling in Boston. Say you have a business trip to Boston, but don't know the area around your hotel very well. How would you explore what's around you ahead of time? If you are sighted, you might use a maps application to explore things around you. Looking at all these points of interest, you can find a restaurant, a cafe, or a store that you want to go to. And since you can see this map, you can see exactly where these places are located in relation to each other. Some people might also use street images, like street side images in Bing Maps. These allow you to see what storefronts look like and even walk around the area to see what's there. However, these services have not been created with visual impairments in mind, since they aren't very accessible. And no other accessible technologies exist that focus solely on exploring an area ahead of time and planning in advance. So we created Virtual Interpretation of Areas, or VIA. VIA is a web application that helps people with visual impairments virtually explore the city of Boston using open city data and AI. VIA presents information through sound and not just visually. You can use VIA on a web browser with a screen reader to navigate through the page. Screen readers are tools that people with visual impairments use to read out information displayed on a screen. You can access every aspect of VIA with a screen reader. And most importantly, you can hear the text box on the left, which includes information like points of interest and street layout descriptions. Each time you move through the map, with the arrow buttons, the text box updates and tells you where you are and what's around you. VIA has 3 zoom levels that give users different amounts of information about their virtual surroundings. The top zoom level, overview, is like driving through an area and getting a brief glance of what's around you. The middle level earshot provides a block-by-block description of potential points of interest in a more detailed form. The most detailed level, touch point, simulates walking along the sidewalk. It describes intersections at a detailed level and provides landmarks for people with visual impairment to reference. In Touchpoint, we trained a computer vision model to identify these landmarks like signposts, which users can hear about in the text box. Hearing where these landmarks are ahead of time can help people with visual impairments localize themselves in front of a building and confirm their location. Going back to the technology landscape, VIA really occupies this space of exploration, and specifically exploration ahead of time. The virtual environment that VIA creates allows people with visual impairments to virtually walk the streets of Boston and get a feel for their layout and things around them before traveling in real time. In summary, VIA helps make the experience around streetside more accessible and helps reduce anxiety related to traveling to new places. It helps people feel more connected to Boston and helps connect the mental maps that people with visual impairments already use. For the project as a whole, we accomplished our goal of creating a prototype that demonstrates the use of AI and open city data in accessible technologies for smart cities. This project can be used as a motivation for future projects, either at Microsoft or as a future scope project. And finally, we have given Microsoft all of our learnings and research from this year to help guide them in future accessibility work. We would like to thank everyone who helped us during this project, especially those from Microsoft and Olin, and all of the local groups of people with visual impairments that we spoke to throughout the year. If you would like to learn more about how VIA works or hear more about accessibility in cities, please come talk to us this afternoon at our poster. Thank you.